Have you ever seen a skid steer loader working on a construction site? You're watching it zip around, and suddenly you notice its tires are dragging across the pavement, squealing, and leaving those aggressive black marks on the ground. You've probably asked yourself, why does it do that? Is the operator driving badly? Is it a design flaw? Or is there a brilliant reason behind all that chaos? Well, don't worry, because in this video, we're not only going to uncover the mystery of the dragging tires, but we're also going to dive deep into the fascinating hydraulic heart of this machine. We'll cover the lift arm system, how to operate it, and the insane variety of attachments that make this the Swiss Army knife of the heavy equipment world. Let's get started. The secret of the skid. It's all about hydraulics. First, let's talk about what makes it move. Here's something wild. This machine has no mechanical transmission. That's right. Open one up and you won't find a drive shaft, a differential, or a traditional gearbox connecting the engine to the wheels. So, how does it move? There's only one answer. Everything is hydraulic. The diesel engine is coupled to two groups of hydraulic pumps. Let's focus on the first group, the one responsible for making the machine drive around. Inside here, we have two axial piston pumps. Each one is connected in a closed loop to a hydraulic motor. One pump sends oil to the left side, and the other sends oil to the right side. The oil doesn't just go to the motor and back to a tank. It circulates constantly between the pump and the motor. This is called a hydrostatic drive system. Now, where are these motors? They are located on each side of the machine's frame. They drive chains, one chain for the front wheel and one for the rear wheel on that side. This is called a tandem drive system. It ensures that both wheels on the left side spin together with equal power. This gives us true 4x4 traction. The big reveal, why the tires drag. And this brings us back to our original question. This is exactly why the tires drag. Because the left side and the right side are powered independently by separate hydraulic pumps, there is no mechanical steering. There are no steering knuckles and no articulated joint like you'd see on a larger loader. To turn, the operator simply tells one side to go faster than the other. To make a sharp turn, one side goes forward and the other goes backward. The tires are literally forced to slide or skid across the ground to change direction. Hence the name skid steer loader. Yes, this causes accelerated tire wear and loses some energy. But the trade-off is incredible. Because of this hydrostatic system, you can achieve a zero turning radius. You can even perform a counter rotation, spinning the machine completely around within its own length. Imagine the right side wheels going forward while the left side wheels go backward. The machine spins on the spot. This makes it invaluable for working in impossibly tight spaces on construction sites, in barns, or on city streets. That maneuverability is why it's a key player in construction, forestry, agriculture, and so many other industries. Keeping its cool, the charge pump. So far, so good, but this closed-loop hydrostatic system has a problem. Heat. Oil circulating under high pressure in a closed circuit gets hot, really hot. To fix this, engineers created a charge pump. This is a smaller pump mounted behind the main pumps. It has a simple but critical job: to feed cool, low-pressure oil into the closed loop. But if you add oil, you have to take some out, right? That's where the flush valve comes in. This valve continuously siphons a small amount of the hot oil from the loop and sends it to the radiator to be cooled. The charge pump then refills the loop with cool oil to replace what was sent away. It's a constant cycle of refreshing the fluid to prevent the system from melting down. The lift and tilt, the second pump group. Now, remember we mentioned two groups of pumps? The first group was for driving. The second group is for working. This is a gear pump, and it handles the lift arm and the bucket. Unlike the closed loop for the drive, this is an open circuit system. The pump sucks oil from the hydraulic tank, sends it to a control valve, and then to the cylinders. When the cylinders are done, the oil returns to the tank. When you pull the joystick, the control valve opens. The more you move the stick, the more oil is sent to the lift cylinders, and the faster the arm moves. Push it forward to lower the boom, pull it back to raise it. Move it left to tilt the bucket back, curl, and right to dump it out. Parking brakes and safety first. You might be wondering about brakes. Interestingly, a skid steer doesn't have traditional service brakes. When you let go of the drive joystick, the hydraulic flow to the wheel motors stops, and the machine automatically holds its position. However, it does have a spring-applied hydraulic release parking brake. Think of it as a safety default. Powerful springs keep the brakes locked at all times. To release the brakes and allow the machine to move, you need hydraulic pressure. This pressure is controlled by a solenoid that activates when you turn off the parking brake switch in the cab. If the machine loses power or pressure, the brakes automatically lock up. Operator control, the joystick dance. Operating a skid steer is all about coordination. Left joystick controls movement. Push forward to go forward, pull back to reverse. Move it left to turn left by speeding up the right side, and right to turn right. This is also the stick you use to perform the famous counter rotation. Right joystick controls the tools. Pull back to raise the boom, push forward to lower it. Push left to curl the bucket, and right to dump it. And before you can do any of this, the machine's safety systems must be engaged. There's a seat sensor that detects if an operator is present. You must lower the safety bar or door around you. Often there's a pin in the door that locks hydraulics if it's open. And finally, the parking brake switch must be on for the engine to start. Beyond wheels, tracks, and attachments. Did you know there are also compact track loaders? Instead of wheels, they have a set of rubber or steel tracks. These are designed for soft, muddy, or uneven terrain where you need maximum flotation and traction. The tracks distribute the machine's weight over a larger area, preventing it from sinking into the mud, a massive advantage in landscaping and site preparation. And the versatility doesn't stop there. A skid steer can use over 50 different types of attachments. Some of the most common are hydraulic hammers, asphalt planers, pallet forks, and multi-purpose grapples. The potential is almost limitless. And here's the best part, connecting them is easy. The hydraulic hoses use quick couplers. You can switch from a bucket to an auger in minutes without needing tools, making this machine a productivity powerhouse. A word of caution. We have to talk about safety, especially on slopes. You need to be extremely careful when descending a hill, especially in reverse. The counterweight at the back is great for stability when you're carrying a load in the bucket, but if you're going downhill with an empty bucket, that weight can work against you, shifting the center of gravity and leading to terrifying tip-over accidents like this one. Always keep the heavy end of the machine pointed uphill. The legacy. The popularity of the skid steer is so massive that they even hold world championships. Operators from around the globe compete in events to showcase their driving skills, performing incredible stunts and precision maneuvers with these agile machines. So, there you have it. The skid steer's dragging tires aren't a flaw. They are a feature of a genius hydraulic system designed for ultimate maneuverability. Did you already know how a skid steer works? Have you ever operated one? Let us know in the comments below. If you learned something new today, smash that like button, subscribe to Motor Vibe Talk, and hit the bell so you don't miss our next deep dive. Thanks for watching, and we'll see you in the next one.